Scientists at NASA had no idea what they were signing up for when they launched their state-of-the-art James Webb Space Telescope on the 25th of December 2021 from the Guyana Space Center. Astronomers were expecting to find clues for life in the atmosphere of distant planets and galaxies, but little did they know that the first images to arrive from the JWST will revolutionize the way we perceive outer space. The mysterious light detected by the incredibly powerful telescope in one of the images might just be the evidence we needed to confirm that another planet out there could have signs of life. NASA has just released the first pictures captured by the JWST, and the American President Joe Biden has accurately called this mission a new window into the history of our universe. NASA Administrator Bill Nelson had promised that soon enough humanity will get an utterly unique view of the cosmos, unlike any that we've seen before. Today we will take a look at the information the James Webb Space Telescope has provided us and what it actually means. Is the peculiar light truly a sign of life or potential life on a planet orbiting an entirely different star millions of miles away? Could it be the super-Earth we're all counting on, and what else is out there? In order to understand what the most advanced telescope in human history has unraveled, we need to take a step back and find out more about this miraculous invention. NASA, along with its two partners, the European Space Agency and the Canadian Space Agency, operates this massive telescope named after James E. Webb, a NASA administrator who oversaw the Apollo program in the 1960s. It cost around $10 billion to build this telescope, but scientists believe that it will more than make up for the time and money invested in creating it. And the images that we have just received from the JWST show that they were absolutely spot on. It is no doubt the largest and most powerful space science telescope in all of human history, but it took NASA around 25 long years to design and develop this masterpiece. Today it is operating at a mind-boggling temperature of minus 266.75 degrees Celsius, which is just a few points below absolute zero, that is minus 273 degrees Celsius. In order to maintain this impossibly low temperature, the James Webb Space Telescope orbits around the Sun instead of the Earth like our very own Hubble does. Around 1.5 million kilometers from Earth, there's a point called the L2 Lagrange point, where the JWST remains at all times. This is how it manages to safely orbit around the Sun while maintaining its optimal temperature. It has been designed to observe a lower frequency range than Hubble, mainly from long-wavelength visible light through mid-infrared wavelengths. It can visualize wavelengths made from 0.6 to 28 micrometers. Its primary mirror is made up of 18 hexagonal mirror segments made of gold-plated beryllium. These combine to form a mirror having a 6.5-meter diameter. The James Webb has two infrared cameras. The first one is the near-infrared camera, also called NIRCam, which captures the shorter infrared wavelengths. The second one is the mid-infrared instrument, or MIRICam, which captures the longer infrared wavelengths. The photos vary depending on which camera was used to capture them. It also uses a 5-layer sunshield constructed from Kapton E to block light and heat from the Sun, Moon, and Earth. So far, NASA has provided us with 5 images captured by this giant, one-of-a-kind telescope. And to say the least, these images are mesmerizing. Stars emitting spectacular blue and orange light, galaxies dancing and crawling around each other in a tangle of stars and dust clouds, and some of the oldest light in the known universe emitted 13 billion years ago. All of this and more has been unveiled by NASA in the press release held on the 12th of July. But if the initial images have disclosed so much, what might the upcoming data from the James Webb behold, and is all of it good news? So far, the information obtained seems pretty harmless, but you never know when things might turn around. After all, NASA is hoping that this telescope will be able to penetrate dust clouds and see light from the far corners of the universe, a universe that could be as dangerous as it is exciting. The most intriguing part of the data obtained from the JWST isn't even a photo, it's actually spectrographic data of the planet WASP-96b. This is an exoplanet around 1,150 light-years away from us. Any planet outside of our solar system is considered an exoplanet. Besides NIRCam and MIRICam, James Webb is also equipped with a near-infrared imager and slitless spectrograph, or NIRIS. It measures the intensity of various light wavelengths. The nearest, mounted on JWST, measured the light coming from WSP-96b for around 6.5 hours and plotted the data obtained on a graph, and according to this data, there might be water on this planet. This mostly gaseous planet measures nearly half the mass of Jupiter. It orbits its home star so closely that 1 year on this planet is equivalent to only 3.4 days on Earth. This quick orbital period is extremely important, as it is the reason why astronomers were able to study how molecules on this planet absorb and then re-emit light from its home star. By breaking down this spectrum of light into its constituent wavelengths, scientists were able to figure out the type and quantity of elements present in the atmosphere of this planet. Graphical representation of this data helped scientists conclude that there is water on WSP-96b. In fact, there's a good amount of water vapors in the atmosphere of this planet. Despite the hope this image has provided us with, it is too hot to harbor any kind of life. The temperature on WSP-96b is around 530 degrees Celsius. But in the coming months, this telescope will be pointed toward a different planet and take images of it. This one is considered potentially habitable, but let's not get ahead of ourselves here. However, scientists do believe they can use spectrum images of many other planets, even outside of our solar system and galaxy, thereby advancing their search for any signs of life in the farthest corners of the universe. Another prime target of the James Webb Space Telescope is the group of 5 tightly bound galaxies around 290 million light-years away from us. This group of galaxies is called Stephan's Quintet and is located in the Pegasus constellation. According to NASA reports, 4 of these super-close galaxies are continuously whizzing past one another at a dangerously short distance, putting them at the risk of collision. The incredibly high-quality image reveals that 2 galaxies in the quintet are in the process of merging into each other. Out of these 5, the leftmost galaxy is closer to our solar system than the others. It's about 40 million light-years away, and that's why the image of this galaxy has a higher definition. Scientists believe they can use information on galaxy groups like this one to understand how gravity behaves at the largest scales. This can also help them learn more about the mysterious, invisible yet massive entity called dark matter that is supposedly holding the universe together. The next image shared by NASA portrays the most stunning cosmic baby boom you will ever see. This bright and glassy hotbed of star formation is located approximately 7,600 light-years from the Earth in the southern constellation called Carina. What looks like a landscape full of mountains and valleys sprinkled with glittering stars depicts the edge of a young star-forming region in the Carina Nebula. Astronomers believe this is one of the most active star-forming regions they've ever seen. It is home to lots of stars much larger than the Sun. Scientists have studied the Carina Nebula in detail previously, but this new image apparently reveals the cosmic cliffs with unfathomable detail. The immensely powerful James Webb Space Telescope is helping us see hundreds of newborn stars that were invisible to older telescopes. NASA officials have stated that this picture is so clear that they can now visualize jets and eddies of dust swirling through the image. They have created mysterious structures scientists can't even identify yet. Using the knowledge obtained from this image of Carina Nebula, scientists want to find out everything they can about the birth of stars. They believe it might even enable them to explore the origins of our solar system. The next image this spectacular telescope brought to light depicts the Southern Ring Nebula. The figure-8-shaped cloud of dust and gases expelled from this massive dying star is the reason why it's also called the 8-burst nebula. It's located nearly 2,500 light-years away from Earth. A fascinating orange foam of molecular hydrogen can be seen swirling around a bluish haze of ionized gas. All this is being expelled by the dying star visible in the center of this image. The mid-infrared image of the same nebula shows a second red star twinkling next to the bright blue one. Now, scientists were always aware that the Southern Ring Nebula was a binary system, but this is the first time the second star has been so clearly visualized among the thick cloud of dust. However, like all the other images captured by the JWST, many clearly visible galaxies seem to be photobombing the background of this image. This points towards all the as-of-yet undiscovered secrets we might soon unravel. Taking a closer look at this image, scientists noticed a small and thin line visible in the upper left part. NASA astronomer Carl Gordon predicted that it was just a part of the nebula, but later, after viewing it carefully with both the infrared cameras, they realized it was the side view of a galaxy. So the puzzling, unexplained light detected by the JWST was actually an entire galaxy we could have overlooked. There's a chance that the dust particles being tossed into space by the dying star could possibly coalesce to form seeds of future stars and planets. Further analysis of this nebula might help researchers understand the cycles of stellar death and rebirth. Before any of the other images captured by the James Webb Telescope took the internet by storm, we were given a glimpse into the deepest image of our universe on the 11th of July 2022. This is an image of the cluster of galaxies known as SMACS 0723.
13 billion years in the making. The White House has revealed the first full-color image taken by the James Webb Space Telescope.
This extraordinarily high-resolution and high-definition picture provides the deepest view of the stunning universe we are a small part of. In this image, we can appreciate the light emitted 13.5 billion years ago. That's pretty close to the estimated beginning of the universe 13.8 billion years ago. This deep-field image from the James Webb Space Telescope showcases its ability to harness the gravitational forces of galaxy clusters. It then magnifies distant galaxies behind these clusters, providing scientists with an incredibly clear view. The SMACS 0723 cluster we see in this picture is around 5 billion light-years away from Earth. The pictures from this ultra-modern magnifying telescope have brought delight and relief to scientists who have been eagerly waiting for this project to succeed. They have high hopes for this mission aimed at transforming our view of the cosmos. However, this wasn't easy to achieve. These high-resolution and full-color images are the culmination of NASA's 20-year-long project to launch a next-generation space observatory, a revolutionary successor to the iconic Hubble Space Telescope. The James Webb Space Telescope is 100 times more powerful than Hubble and is now fully booked for its first year of scientific operations. Scientists are hoping to make trailblazing discoveries using the information obtained from this telescope. Whether it's black holes or cosmic expansion or even the earliest origins of stars, science is on the verge of exploring unfathomable possibilities on all fronts thanks to this extraordinary invention. Do tell us in the comments what you think about this groundbreaking, ultra-advanced telescope and the baffling insight into the cosmos it has provided us.